So we'll have a look at the concept of variation, direct and inverse variation. And this may seem like something very new and strange, but this is something you already know as proportionality. You have this strange new symbol here, which I've never seen before, and you're not going to find it in Microsoft Word either. This one is perhaps familiar. So we can use it like this, or we can also use it like this and say that y is proportionate with x, or that we have either direct or inverse variation between the two variables. And what this means is, well, if you have direct variation, if x increases, then y increases as well. And this would be a linear equation where you don't have this extra constant, but rather you have just a number that is multiplied with x. And you know that this line would also pass through the origin. If we look at how this looks in GeoGebra, we could just write hang on, the equal sign. Okay, so this is the equation y equals x. We could put in a number here, and this would be the k. And depending on the number that we put in, you could change the steepness of the line. So that's direct variation. This is direct variation as we know it from earlier math courses, where you simply have the variable x. Now, this could also be a power number. Let's see. So it could be x to the power of something else. Just get the formula, u that on. Yeah. There, so we could change that to x to the power of 2 or x to the power of 3. And then these, the graph of these functions would look different. I mean, if we changed the x to x squared, we know that this function is going to look different. If we change this to x to the power of 3, it's going to look different again. So that's direct variation. We have a relationship between x and y, which is defined by a constant multiplied with the variable x. And x can be either in the first or second or third power. But there are no other terms in the equation itself. So there's no plus or minus something else. Indirect, no, not indirect, but inverse variation looks something like this, right? So that rather than multiplying with k, we divide by the variable, so k divided by x. If k is 1, then this is not going to be a straight line like you had with y equals x. So we'll have a different function called g, and we'll take 1 divided by x and see what happens. And you get something like this. So this is the inverse variation function, 1 divided by x. And if we try that with a different power, it's going to look stranger still. We could certainly try that. Let's see. 1 divided by x to the power of 2, for example, would look like this. And 1 divided by x to the power of 3 to look like this. We could try 2 to the power of 2 divided by x to the power of 4. Okay. So we're not going to try to memorize what these different inverse functions look like, but the main principle here is that you have two different types of functions, and one is called direct variation and the other one is called inverse variation. And since these power numbers can vary, we'll just put in n rather than an actual number. Let's see, let's put in, oops. X to the power of n here as well. Or rather like this. Okay, so just a little explanatory text here. So this is in direct variation. And this other bit here is in inverse variation. There. In the next video, we'll look at examples of both.